In this video, we're going to focus on using the Gaussian elimination to solve a system of equations with three variables. So let's start with this problem. Let's say we have x plus y minus z is equal to -2, and 2x minus y plus z, let's say that's equal to 5, -x plus 2y plus 2z, and let's say that's equal to 1. So how can we use matrices to solve this system of equations? The first thing we need to do is convert it to an augmented matrix. So let's write the coefficients in this matrix. So we have 1x plus 1y minus 1z, and let's use a vertical bar to separate the left side from the right side of the equation. So I'm going to put -2 on this side. Now for the second equation, the coefficients are 2, -1, and 1. Now for the last equation, it's -1, 2, 2, and 1. Now what I'm going to do is convert this matrix into row echelon form. So I want these three numbers to be 1, and I want these numbers to be 0. So let's make those three numbers in blue 0 first. So what I'm going to do is I'm going to add row 1 and row 3 together, and I'm going to apply that change to row 3. So first, let's rewrite the matrix. The first row is not going to change. All of the changes will be applied to row 3. So I can rewrite row 1. Row 2 is not going to change. Now, row 1 plus row 3. So for column 1, it's going to be 1 plus -1, and so that's going to be 0. And then it's 1 plus 2, which is 3. And then it's -1 plus 2, which is 1. And then it's going to be -2 plus 1, which is -1. Now the next thing I want to do is convert this 2 into a 0. So I'm going to apply the changes to row 2. I'm going to multiply row 1 by -2, because this will become -2, and then add that to row 2. So I'm going to write it out step by step for this one. So here's the operation that I'm applying. It's called a matrix row operation. So for column 1 and in row 1, we have an entry 1. So R1 is going to be 1. And for row 2, column 1, the entry is 2. So -2 plus 2 is 0. So this is going to be 0. Now for column 2, we're going to use these two numbers. So in column 2, R1 is 1, and R2 is -1. So this is going to give us -3. Now, for column 3, R1 is -1, and R2 is 1. So -2 times -1 is 2, and then add 1 to that. That will give you 3. Now, for the fourth column, R1 is -2, and R2 is 5. -2 times -2 is 4, plus 5, that's 9. Everything else will be the same, so let's rewrite the other numbers. And then let's get rid of this. So what do you think is the next thing that we should do at this point? Now, we need this number to be a 0. So all we got to do is add rows 2 and 3. And we need to apply the changes in row 3. So it's going to be R2 plus R3. So row 1's and row 2 will stay the same. So if we add R2 plus R3 from column 1, that's 0 plus 0, so that's equal to 0. And for column 2, R2 plus R3 is going to be negative 3 plus 3, which is 0, which is what we want. And then for column 3, it's 3 plus 1, which is going to be 4. And then for the fourth column, 9 plus negative 1 is 8. Now, if I wanted to, I can convert this back to a system of linear equations and use back substitution to get x, y, and z in this form. But what I want to do is convert it to row echelon form. So I want to convert these 3 numbers into a 1. I don't need to change it. This is already a 1, but these 2, they need to be converted into a 1. So therefore, simultaneously, for row 2, I'm going to multiply it by negative 1/3 R2. And for row 3, I'm going to multiply it by 1/4. So row 1 will not change. So let's rewrite that. And row 2, we're going to multiply everything by negative 1/3, or divide everything by negative 3. So negative 3 divided by negative 3, or negative 3 times negative 1/3, that's positive 1. 3 times negative 1/3 is negative 1. And 9 times negative 1/3 is negative 3. Now, 4 times 1/4 is 1. And 8 times 1/4 is 2. So now what we need to do is convert this back into a system of linear equations. So column 1 is the coefficients for x, this is for y, and z. So the first equation is x plus 1y minus 1z is equal to 2. For the second one is 1y minus 1z is equal to negative 3. And the last one is 1x is equal to 2. So in this form, we automatically get the solution for x. Now, it shouldn't be x, it should be z, because this is the column for z. So we should have that z is equal to 2 and not x. So we have the solution for z. And one other thing I missed, this is negative 2. I forgot to transfer the sign here, so that should be negative 2 as well. So now that we have z, let's plug it into the second equation to get y. So y minus z, or y minus 2, is equal to negative 3. Now let's add 2 to both sides. So negative 3 plus 2 is negative 1. Therefore, y is equal to negative 1. Now let's take y and z and let's plug it into the first equation. So we're going to have x plus y, where y is negative 1, minus z, and z is 2. That's equal to negative 2. So negative 1 minus 2 is negative 3. And if we add 3 to both sides, negative 2 plus 3 is 1. So x is equal to 1. Now we have the final answer. So in the form of x, y, z, it's going to be 1, negative 1, comma 2. So this is the solution. And keep this in mind, this form is row echelon form, where you have a diagonal of 1s and 0s beneath it. It really doesn't matter what's here. So keep that in mind. So that's the row echelon form.